We are going to solve one example using the method of separation of variables. This is a PDE. This is a second order partial differential equation. It means we are going to resolve into two differential equations. Is that clear? So let us go. Let's write solution. Partial square z all over partial s square minus 2 partial z all over partial x plus partial z all over partial y equals to 0. Let's name this one equation 1. Now, I want to use separation of variables to solve this PDE, partial differential equation, second order PDE. But what we will do first is we are going to how can we obtain the solution of this PDE? By let z equals to x of x, then y of y. We made this one equation 2. It means we are going to differentiate this function partially with respect to x and y. But note that the x here, we have partial square z all over partial x square. So it means x is going to be differentiated twice. Then we substitute it into the formula, into this partial differential equation. Let's differentiate this function. It means partial z all over partial x is going to give us y dx all over dx. Is that clear? Then x is a function of x. Then we assume this one to be equation 3. Then differentiate it again. If we differentiate equation 3, it means we have partial square z all over partial x square is equals to y d square x all over the x square. This is equation 4. Then we are going to differentiate equation 2 partially with respect to y. So if we do that, we are going to have partial z all over partial y is equals to x dy all over dy, which is equals to equation 5. Then what we need to do here is we are going to substitute in equation 3, 4, and 5 into equation 1. Is that clear? We write putting equation 3, 4, and 5 into equation 1. So if you agree with me, it implies that anywhere we see this, we write this. Anywhere we see this, we write this. Anywhere we see this in equation 1, we write this. So if you agree with me, here will be y d square x all over the x square, then minus 2 d here y dx all over dx, then plus here x dy all over dy. Is that clear? Which is equals to what? 0. Do you agree with me? So if you agree with me, it implies that at this point we are going to divide Okay, at this point, if you can see what I am saying, are you seeing what I'm saying? Okay, yeah, this one give us this guy, this one give us this guy, then this one give us this guy. Okay, so if you agree with me, we are going to divide 2 by xy. At this point, divide 2 by xy. If you agree with me, it means we are going to have y all over xy d square x all over the x square minus 2y, amen, all over x y dx all over dx, then plus x all over x y dy all over dy equals to k, because of we are going to obtain 2 differential equations. So you equate it to what? A constant k. Is that clear? So if you can see what I am saying, this and this will go, this and this will go, this and this will cancel. So we are going to have 1 all over x d square x all over the x square minus 2 all over x dx all over the x, then plus 1 all over y dy all over the x equals to k. Is that clear? Now this is 2 differential equation. If you can see what I am saying, this is 1 differential equation, second order differential equation, while this is first order differential equation, equate it to k. So you equate the 2 to k. So if you can see what I am saying, it means we are going to equate this to k d square x all over the x square minus 2 all over x dx all over the x equals to k. And this, this one crosses the sign of equality, becomes minus. So here we are going to have minus 1 all over y dy all over dy is equals to k. So are you seeing what I was saying initially? I said after solving this second order PDE, we are going to resolve into what? 2 differential equations. Is that clear? Do you understand? Okay? So if you agree with me, let's look at it together. If you agree with me, let us first consider one after another. Okay? So if you agree with me, it implies that we are going to take LCM. The LCM will be x, 2 of us. The LCM will be x. So x to x 1 times, we are going to have d square x all over the x. That clear? Then minus x to x 1 times 2 dx all over the x, then equate it to what? K equals to k. So if you agree with me, we cross multiply. This one multiply this. So our d square x all over the x minus 2 dx all over the x is equals to kx. So if we take this to the left hand side, it means this differential equation will now be in this form. Sorry, this is s squared. Please, sorry, s squared. Is that clear? So minus 2 dx all over dx minus kx equals to 0. Amen? So now, how are we going to solve this differential equation? It means we are going to let x equals to exponential mx. Is that clear? So, when I take this part, it's okay. Mx, exponential mx. Okay. It's not difficult. Just follow me on YouTube. Okay. Exponential mx. Okay. So let's differentiate and substitute into this second order differential equation. So it implies that our x prime will give us m exponential mx. Then our x prime is equals to m squared exponential mx. Is that clear? So what we need to do, we have to substitute it here. So here will give us m squared exponential mx minus 2m exponential mx, because this is first order differential. We just differentiate it once. This one we differentiated it twice. So minus our k, where we said let x equals to this. So k exponential mx equals to 0. Do you agree with me? Okay. So if you agree with me, look at this equation. What is common? Exponential mx. Exponential mx, factor it out. Then we'll have it in this form: 2m minus k equals to 0. Then, if exponential mx not equals to 0, it implies that our auxiliary equation is this: m squared minus 2m minus k is equals to 0. It means we are going to obtain our m1 and m2 by using formula method. Is that clear? Using formula method. Okay. Now write using formula method. It means our m is equals to minus b plus or minus square root of b squared minus 4ac all over 2a. So if you agree with me, it implies that our just like we have ax squared plus bx plus c equals to 0. So here our a is equals to 1, then b is equals to minus 2, and c is equals to minus k. Is that clear? So our m is equals to minus all in bracket minus 2 plus or minus square root of all in bracket minus 2 square minus 4 times a times minus k all over 2 times 1. Is that clear? So if you agree with me, our m is equals to minus times minus 2 plus or minus. Here will give us plus 4, and here will give us plus 4k all over 2. Is that clear? So if you agree with me, it means at this point, you don't need the prophet to tell you. Let us transform the square root in this form. What is common? 4. Factor it out. Then we have 1 plus k all over 2. Okay, now go back to your sort. If we have, assuming if we have square root of 4 all in bracket 1 plus k close bracket, this is the same thing as square root of 4 times square root of 1 plus k. True or false? So yes, true or false? So if you agree with me, it implies that here it means square root of 4 will give us 2 times square root of 1 plus 1 k. Exactly. But note that if we have plus or minus, it means it is either plus or minus. So let's go start with plus. So if our m is equals to 2 plus square root of 4 all in bracket 1 plus k close bracket, it means this is the same thing as 2 all over 2. This and this will cancel 1. Then our m is equals to, if we apply this, it means here is 1 plus square root of 2 root 1 plus k all over 2. Then this and this will go. True or false? Our m is equals to 1 plus square root of 1 plus k. Is that clear? So we are going to stop here. Then I'm going to continue this problem in next video. Thank you and God bless you.